Okay, so we're going to use, again, the uniform acceleration equation to find, this time, the final velocity of v. So, as always, we're going to start off by highlighting our information. So we're going to highlight what we know and what we need to find out. So starting off, the car accelerates from a starting speed, so starting speed is initial speed of 5 meters per second. So I'm going to highlight that, 5 meters per second. At a rate of 4 meters per second squared. Now it's not clear that that's the acceleration, but the meters per second squared tells us it's got to be our acceleration. The car does this for 200 meters, so a distance. How fast will the car be going at the end of this? So how fast, that tells us that's going to be our final velocity. Okay? So, then writing our numbers out, we know that v squared is, well, we don't know what that is. That's going to be a question mark. We do know what u squared is. Oh, so we don't even need the squared now. So u is 5 meters per second. Don't need that u squared. We know that acceleration, or a, is 4 meters per second squared. And we know our distance, s, is 200 meters. Okay, so straight away, going to get on to writing out our equation. So we've got v squared minus u squared equals 2 times a times s. Right, now all we need to do is substitute our numbers in. So we don't know what v is yet, so we're still going to leave that as v. So we're still going to be v squared minus, we do know what u is, it's going to be 5 squared equals 2 times, we know what acceleration is 4, times, and we know that the distance is 200. Okay, now we can start working things out. So, look at what we can do on both sides. So we split the sides up now. We're going to do this side separately to this side. So on this side we can do 5 squared. So 5 squared is 25. So it's going to be v squared minus 25 equals, and then we're going to do the other side, 2 times 4 times 200 is 1,600. Now, this is the kind of tricky bit. It's v minus 25, v squared minus 25 equals 1,600. So we need to work out what v squared would be if we weren't taking the 25 away from it. Okay, so what we need to do for that is move the 25 over to this side. Because it's minus on this side, it's going to be plus on the other side. So v squared equals 1,600 plus 25, and that's quite easy to do. So v squared equals 1,625. Now I've still got a bit of a problem though, because we've got v squared and we don't want it to be squared. So to find that, we need to square root the answer we've got, so that v equals, let's do the square root of 1,625 is 40.3. Okay, and because it's a velocity, the final velocity is meters per second squared. So we don't want v squared, we want just v. We want the final speed, not the final speed squared. So what we need to do to that is square root both sides. So our square root's the v squared to v, and we square root 1,575. Okay, so do the square root of 1,575 That gives us 39.7. We'll round it to one decimal place. Okay, so 39.7, and that is going to be meters per second, the units. So similar again, only difference is moving this over here, so it's not timesing and dividing opposite this time, it's plusing and minusing, and at the end we have got to square root because of the v squared. Yeah. Okay.